Pointing devices. Pointing device is a hardware input device that allows the user to move the mouse cursor in a computer program or operating system. Some types of pointing devices are a computer mouse, a finger on a touch screen, a light pen, a trackball, a touchpad, or something as simple as a keyboard. Touchscreen. A touchscreen is a monitor or a flat surface with a sensitive panel directly on the screen that registers the touch of a finger as an input.
Resistive. Resistive is the most basic and common type of touchscreen. These screens literally resist your touch. If you press hard enough, you can feel the screen bend slightly. This is what makes resistive screens work too. Electrically conductive layers bending to touch one another. Capacitive. Surface capacitive uses sensors at the corners and a thin, evenly distributed film across the surface. When a finger hits the screen, a voltage drop is created and electrical charge is transferred, which makes the screen move.
New creations. Air mouse. The device's ability to work while detached to the user's hand without the necessity to roll it on the desktop. This latest invention uses an optical laser. The new computer mouse stays inactive when you place your hand in a flat position, which allows you to easily shift from typing to using the mouse.
How the air mouse works. You can control the mouse cursor in the air easily. The uses of neoprene and silicone materials make its weight only 37 grams and easy to wear. With the 3 buttons and wearing designs make it work as a traditional mouse. Attached to your hand from the back side, this glove also has a button on the index finger portion, and to move the mouse cursor, all you have to do is press the button with your finger. To perform the right click or left click, the button has to be pushed. Now to stop the cursor movement, in case you have to use your hand for other tasks, there is a pause button.
Here's how the Air Mouse works. At the core of the Air Mouse are 3 basic components: the support structure, the tracking device, and the mouse click buttons. The scientists at DMARC worked with a team of medical doctors and hand specialists to examine the ligament and tendon structures of a hand. They identified the key ligaments used in computer mousing, and based on their findings, our scientists built a support structure that assists the hand in maintaining a healthy, neutral hand posture during mousing.
The total cost burden for carpal tunnel syndrome approaches $7.6 billion per year in the US. The problem is that from onset of symptom to resolution of the disease can often take upwards of a year for a patient. When patients use computer mice, they are forced to move their wrists in radial and ulnar deviation, flexion and extension, and there's direct compression on the carpal canal from the surface below. All of these serves to increase pressure within the canal and increases the severity of symptoms. The Air Mouse allows a patient to continue using a computer mouse with the wrists supported in the neutral position and without compression. We believe that the Air Mouse can reduce symptoms, may halt progression of the disease, and can allow a patient to continue their daily activities in a pain-free environment.
With the standard mouse, the tracking device is separated from the hand, which causes the user to move their hand and wrist in strenuous and dangerous positions during mousing. With the Air Mouse, by placing the optical tracking device on the support structure at the base of the thumb, mousing movements are generated from the elbow, causing less angular wrist strain, increasing blood flow to the hand, and improving mousing speed and accuracy. The Air Mouse has a left and right mouse click button, just like a regular computer mouse, so input function is the same. When the Air Mouse is lifted out of the mousing position, the optical piece is no longer in contact with the surface, so you can type and mouse intermittently. You can also perform other office functions like writing, getting paper, or even drinking a cup of coffee. On the Air Mouse, the electronics are separable from the wearable support structure, so the user can replace the glove component when it wears out. So why the Air Mouse? The Air Mouse is an evolution in mousing technology. It's invisible by function and a billboard by design. It's an evolution in mousing technology because it's the same motion you've always been using, except it's faster, more accurate, and has less associated RSI-related pain. It's invisible in function because we've gotten rid of the mouse in mousing. To computer mouse now, all you have to do is place your hand on a surface and move it around. And it's a billboard by design because much like iPods and cell phones, your computer mouse isn't something you leave in your bag or at home. It's something that you take with you everywhere you go. For more information, please go to our website.
Computer monitor, it will allow the computer to determine where on that screen the pen is pointed. The user brings the pen to the desired point on screen and presses the pen button to make contact. It facilitates drawing images and selects objects on the display screen by directly pointing to the object with the
There are
pen.
two layers in resistive touchscreen, the conductive layer and the resistive layer. These are separated by tiny dots called spacers. The electric current runs through the yellow layer at all times. But when you touch the screen, the resistive layer comes in contact with the conductive layer. Thus, the electric current changes at that point of contact, and the function corresponding to that point is carried out. Resistive screens are durable and consistent, but they're harder to read because of multiple layers which reflect more ambient light. Ambient light is the surrounding light reflected back from the screen, making the text harder to read. Unlike resistive touchscreens, capacitive screens do not use the pressure of your finger to create change in the flow of electricity. Instead, they work with anything that holds an electric charge, including human skin. Capacitive touchscreens are constructed using materials like copper or indium tin oxide that store electric charges in an electrostatic grid of tiny wires, each smaller than a human hair. There's a glass substrate, a conductive layer, a protective coating, a controller, and electrodes at the corners. The electrodes apply a low voltage to the conductive layer, creating a uniform electrostatic field. When a finger hits the screen, a tiny electrical charge is transferred to the finger to complete the circuit, creating a voltage drop at that point on the screen. The location of this voltage drop is recorded by the controller. And this is how a capacitive touchscreen works. If you like this video and you want to see more, you can subscribe here. Or if you have an idea for a new video, you can leave it in the comments section below. And if you want to try some other cool science videos, try this link.
Trackball. A trackball is a computer cursor control device used in many notebook and laptop computers. The trackball is usually located in the front of the keyboard toward the user. The trackball is an upside-down mouse that rotates in place within a socket. The user rolls the ball to direct the cursor to the desired place on the screen and can click one of the two buttons near the trackball to select desktop objects or position the cursor for text entry. How the touchpad works. The touchpad contains several layers of material. The top layer is the pad that you touch. Beneath it are layers containing horizontal and vertical rows of electrodes that form a grid. Beneath these layers is the circuit board to which the electrode layers are connected. The layers with the electrodes are charged with a constant alternating current. As the finger approaches the electrode grid, the current is interrupted and the interruption is detected by the circuit board. Thanks for watching. Have a great week.